He has 12 patents to his name. He received 3 academic awards, 12 Best Paper Awards, 6 Best Thesis Award, 4 Professional Awards, and 25 Student Award. He has received the Career Award for Young Teachers in 2002 from Government of India. He is on 12 general editorial boards. He is an associate editor of IEEE IEEE Industrial Electronics Technology News, Swarm and Evolutionary Computation, Elsewhere, IET Renewable and Power Generation, IET Power Electronics, International Journal of Bio-Inspired Computing, and Deputy Editor-in-Chief for CAAI, Transaction on Intelligence Technology, IET. Dr. Kumar is a senior member of IEEE USA and fellow of IET UK. He is also a fellow in IE India, fellow IETE, life member of CSI, senior member IANG, and life member of ISTE. He was a honorary secretary of IETE Rajasthan chapter and ex-com IEEE Delhi PES IAS and vice chairman of IEEE Rajasthan subsection. So I will give my mic to Dr. Rajesh so that he can give his talk and share his knowledge with us. So to Dr. Rajesh.
Okay, yeah, thank you very much and good afternoon to everyone. I hope I am audible to all. Please confirm if there's a delay in the sound. Am I audible?
Yes, sir, you are audible.
And my screen, just give me a second. My screen is visible to everyone?
Yes, sir, we can see your screen.
Okay, fine. So, yeah, just give me 1 second if it is working. Yeah, so a bit change on the title as a part with the discussion uh, with the organizers. Today our agenda is we try to understand some aspects of machine learning so that we can make intelligent systems there. Uh, and then what are the different components of machine learning? What is the progress? How you can use it, and then later I'll take few case studies where we have successfully implemented. EV will be a part of it, so we can discuss there itself in a detail that how we can apply machine learning to EV. So talking about the system, intelligence comes from something which is from either uh, like, uh, getting a training through a system, or having some experiences, or having some knowledge bank, or interpreting some of the results there. So that is exactly what machine learning and AI normally do. Let's take it from this one. Say that I have one vehicle, which is a very this one is conceptual figure, which can be further realized on the actual scale. So this car is not this one is remotely operated, or you can say it's just self operated car. What we can do from here is we apply some sensors, okay, maybe IR sensor, some any kind of a sensor. So which what is the job of that? These sensors give us in a sense the surroundings and give us the information in terms of some signals which we can consider as a data. So we can process it through some kind of converters, and then these the data which we, or the signals we receive from the converters, they are in the form of certain data. So this is a simple pipeline. Like every time when you talk about intelligent machines, intelligent systems, uh, and the theme of the course is like how you can implement these things in the real world. So always you have one system, then we have some kind of a sensors, then we have certain kind of a converter mechanism, which finally give us the surroundings in form of a data, which we take it to the computer there. Once we have these data with us, the data is huge in number. Something is in the when we are taking these data, there are noises. There may be some meaningful data, some unwanted signals, and all that. So what we do, we apply certain kind of techniques to understand it. That okay, what are the meaningful things for us, and then from there, once we have a meaningful things, then we apply certain kind of techniques or mathematical combinations so that we can connect the data, we can connect the dots basically, that what is the meaning of this data, and then how these data can be used for controlling the process, or predicting certain things, or inferring certain things. So that is basically AI comes into the picture there. And then AI or those mathematical combinations give us certain outputs, or as well as give a certain kind of analysis. So that is basically data analysis we can perform. What are the impacts, and some studies there. And finally we put it onto a different level, and you can have another version of the car, which is a smart car. So that is how you can have a simple car, you can convert into a smart car, or self-driven car, or something like that. So that is basically the pipeline you will find in almost all the process there when we talk about intelligent systems, or anything like that. We have physical system, old system, put the sensors, get the signals, process it, get the data, further processes using mathematical approaches, and then from those outputs, you can have another kind of upgradation of the things, and that is how these things happens. So this is how it is happening there, and from here we can see that okay, one part which is very important, which change whole of the scenario, and that is basically AI and machine learning is a part of it. I will take few examples which are from different domains, so that we can have a common understanding, instead of having a typical understanding of AI, common understanding that okay, how what is the effect there. So this one is a very interesting work which was done by S. Kundo. That is some images are there. These are images taken there, and from these images, the conclusion generated by the doctors is that there's no osteoarthritis in the 3 years. Okay, and then we have another image set of images, and then it is like osteoarthritis in 3 years, and then yeah, when you put them together, it's many times difficult uh, for a doctors, or many times they don't have that much of time, then may not be able to detect it very accurately. There we need certain kind of a processing through the computer, so that a computer can assist them to make their decision. Not only that, they can even predict it, like what is AI that can see that okay, it is not today, but can we find out, or can we give a certain kind of a confirmation that okay, there will be osteoarthritis in 3 years or after 5 years, something. So we are predicting the things before they actually happen, and that will help us in making the things better basically. So this one is one example of medical application. There is another work which was done very interestingly, and it affects everybody's life also as on today. Those are known, and this one is the prediction, and this work was done by Kosinski. And they basically collect the data, and then data in the form like they get some surveys, manual surveys, and later on the surveys in the form of a digital form also, and from there they try to predict it. So they worked on uh, Professor Kosinski and his team normally, I mean, they worked on Facebook data, and then come out with a very interesting outcomes. Okay, so like in 2012, if there are 68 Facebook Live, likes, so they can even easily predict what is the skin color with the 95% accuracy. So this is something very out of the context. Like we are just watching the likes and all that, and then from there we are predicting what is the skin color, and likewise. Uh, Even other things will be. They have published some very nice outcomes of their work. Like even they can go for, okay, uh, what is the likings on the type of the party, whether it's Democratic or Republican, with 85% accuracy and all that. And not only this, they can, like if we have a data, uh, some likes on certain person, 68 likes or 100 likes. So we can even predict, okay, intelligence of a person, religious affiliation, alcoholic or not, drug uses or not, and many more things. Now these things are doctors are using for various treatments, psychological behaviors, and all those things. Other than that, uh, yes. Industry people, they are using for their own purpose, so that may be multiple fold there. So they refined it, and then they reduce they do did various improvements on the various models, which keep on penetrating into depth, basically, not only about that particular person but about the friend of friend and something like that. Okay, so you can see here what the friends knew. So see, if I want to understand something about a certain person, I need not to talk to that one. What I can do is I can make a chain, and just try to find out who is his friend and who is his friend, and somehow somewhere in the chain, if I find somebody is my friend also, then it's very easy to connect the dots and find out, okay, how, what is the behavior and what type of person is he is or there. Like if we have 150 likes, then we can talk about their person parents and all those things there. Okay, uh, 70 likes, 150 like 300 like, this means the data. So more data we have more, we can knew more about the things, and likewise. So this is basically these things are means like possible through some kind of intelligence, which is not like human intelligence. We have created on artificially on that, and that's the how the term comes into it. That is intelligence exhibited by machines. So that is known as your artificial intelligence, and always it try to look for maximization of the chances of the success. So that's how people that's how people keep on updating or modifying various models there. So there are certain goals of AI before, like we move on. Okay, we have to apply, but we need to understand that, okay, we are going to apply. So where to apply and why and all these things. The goals are like AI must they have developed algorithms that human use to deduce uh, or certain kind of connections, some reasoning, try to find out certain reasoning, and if the problems are complex, we try to find out the complex problems. Another one is how to represent the knowledge which we have in various forms. It helps us in planning the things, scheduling the things in the most appropriate manner. Because when you plan it, it will be a chain, and then we need to see that, okay, how long we can go in a correct way, and likewise. A very interesting application which is now very popular, that is NLP, natural language processing. Talk, putting your machine to talk to you. That is now we are using it. Your mobile phone is one very good example. You just speak it, and then it type the things in the way, or you can use Siri to talk, to play the music. And nowadays in cars, okay, you just give a voice command and it operate accordingly. So this one is another interesting part of it. Robotics, we always talk about, where we do multiple things, basically. Not only we control the motion, we look, okay, robots to move from one place to another place, and we have manipulators. So there is a lot of complexities in terms of environment, it keep on changing. The boards they are moving. Boards they're trying to understand, they try to understand the environment, try to map it. There's electronics involved because we need to control the motion, and we need to pass the communication to the boards there. Electrical is involved when we talk about, because the motion is done by your electrical motors and all that. The stability, the dynamics, that comes from the mechanical part of it. So it's a very unique area or unique domain where you find the electrical, electronics, computer, IT, mechanical, all are involved in it, and there we have very strong applications of AI. Yeah, we are looking for our machines to have perception abilities, so that they can deduce something from it. So we have a lot of sensors like cameras, microphones, sonars, or some in another form where we are taking inputs from the outside world. But then those inputs are there in your computing system, but we want our algorithms or computing uh, computing mathematics so that we can develop certain kind of a perception from those things there. So this one is a, and then these are the things what we expect in future. More stress is given to what about social intelligence, journal intelligence, and then the creativity. We want our machines to be creative in future. It's not like pre-programmed things. What we want is they take the inputs, understand the inputs, understand the change in the parameters, understand the change in the environment and surrounding. From there, they develop certain kind of perception, and then from there, uh, they do some kind of a creativity to solve certain kind of a problem and all that. So these are the few things which we say that these are the goals of AI. So let's see how it is evolved. Initially, reactive machines comes into the picture. In reactive machines, there is no past memories. It's input and output straightforward, no memories there. So what is the current situation based upon the action will be taken, and then there are certain developments. So you can say that reactive machine example is like playing chess with some level of chess with the computing system. And then comes your AI with the limited memory. So a few past data we store, we keep it there, and then we try to represent the environment also. So that as example, one of the good example is your self-driving vehicles. And then the future we are looking for theory of mind. So that is now we are somewhere in between that. You can see the journey from AI limited memory to the theory of mind. What we are expecting in the theory of mind is representation about the world, a representation about the others, what they are doing, interacting with them. And not only interacting, you can see that machines they will take some actions uh, based upon other sections. So that is how our that is theory of mind. And then last level what we are expecting is self-awareness, that is putting emotions and then anticipation of reactions of others. So this is what is we can say in means like journey is quite big, but these are the main, we can say, four groups we can put it. We can say that group of stoppages of your AI there. And where is AI? Let's talk about some applications part. It's everywhere. So, like you say, data analytics, marketing, sales, transportation, education, robotics, healthcare. Few of them I'll discuss here, and then in the end, I'll discuss some of the case studies also. Uh, so, like if we talk, divide it further, okay, healthcare. So we have patient care, we have diagnostics, then we have R&D, and then we have management. That these are the major, some of the areas. Data analytics, you can say predictive analytics, social media analytics, data engineering, language processing, and all that. If I talk about the EV or transportation, we can say traffic management, autonomous vehicle management, and others, and they are interconnected with each other. So it's not like the one is isolated, because we use data analytics for transportation part and all that, and we use data analytics in healthcare also. We use robotics, some part in healthcare. We have very intelligent and good robots being used to perform certain operations. And robotics, yeah, when you talk about autonomous vehicle, that comes under that category. So they are intermixed with each other. Some of the applications, as well as some subcategories, you can say, that is basically language processing, machine learning, speeches, vision, planning optimization, robotics, expert systems. So we what we can do is we can classify the things, we can do some translations, and then data extraction. So that is basically normally we do in language processing. We classify the things, and then either we translate it, or we try to extract the data from what we already have. Machine learning, yeah, a lot of things are there, but very popular are your deep learning nowadays. Predictive analytics is one of them. Speech, we look for text to speech or speech to text or something like that. Machine, okay, when we're talking vision, so machine vision and image processing, and rest we already discussed there. So these are the like categories, and there are a lot of other things are there. I'm just highlighting few of them for you, so that we can have just a idea like how the things are given. When we are talking about the techniques, okay, there are a lot of approaches people have developed, and yeah, many times they divided in a different ways that okay, how to categorize it. Uh, let's take it that various terms being used in AI community when we talk about, okay, what are the techniques. So one of them is your supervised approach. Supervised means there is somebody, some supervisor is there, and the job of the supervisor is to tell you whether what you have done is correct or not. Okay, so when we talk about supervised techniques, we have one kind of a system where we give an input, it generates certain kind of output, and there is somebody to tell that whether your output is correct or not. That means the person who is there, he knows the outcomes of that one, and you can take it other way. That means when I talk about the algorithms, that means what should be the output if I give this input. I know that. Okay, so that means that there is a labeling of the data. That okay, if this is the input, then it should be the output. There is some label kind of things there, and we use these labels to remove our error. So what normally we do? We just give one input to a system or to a mathematical formulation, or good way to say, to a model. It will generate certain output. We know what should be. We know the correct output. There is a difference, and that we call it error. And then we modify the parameters of model in such a way that that error is minimized. So that is basically a supervised way of learning. There is another way of learning, or another way of modeling technique, and that is unsupervised. That means there is no any supervisor. So that in that kind of a scenario, the problem formulation is like we try to find out some kind of some by some approaches the similarity between the things, so that we can cluster them, we can group them, and that is basically known as unsupervised. So unsupervised, no supervisor, that means no labeling of data as such. So we have unlabeled data, and we try to group it to find by finding the similarity between the things there. There is another one which is known as reinforcement learning. Reinforcement learning is basically it is a kind of a hybrid kind of structure, where reinforce, we forcefully, means we put certain kind of force to the model to learn from the environment. So this one is a very interesting approach in a way that, let's say a robo is there, or some system algorithm or robo, whatever you can say. So normally we call those as an agent. So there is one agent, and this agent performs certain action. So when it performs certain action, this action goes to the real environment, and then environment will send the signal, two signals to it. Okay, uh, uh, or you can have only one signal, that is reward. Reward in the sense whether your action is good or bad, in terms of some numeric terms or something like that. So based upon that reward, this agent have certain kind of policy, and based upon the reward, whether it's a positive reward or negative reward, and the policy, it will decide what should be the next action. And that is basically it learns the things in interacting with the environment, and that is basically reinforcement learning. There are a few other terms which are known as like heuristic and meta heuristic. These are basically random process based approaches. So there are two kind of approach. Normally we have deterministic and heuristic. Deterministic means we know each and everything, like what is my start point, and then what will be the value of particular parameter after 10 iterations, something like that. In heuristic or meta heuristic, everything is randomness is there, and that randomness is being used. Mostly these approaches, heuristic and meta heuristic, they are used for optimization techniques to find out the best possible solution there. Another one is your Markov decision process. So this one is a decision process that is okay. How the next happening depends upon present happening, and then there are two most common approaches. One is Markov chain, and this process basically connect the states so that a decision can be taken in a way that it maximize our whole profit. So one is Monte Carlo, another one is Markov process. These are basically uh, normally people use in most of the discrete form of approaches. This one is reinforcement learning. One good example. Now let's extend it. So you can see on your slide on the left hand, you can see there is one agent which is in the form of a bot, and the environment is there. Okay, there is a fire, and you can see there is a bucket, and then uh, and the water is there. So it performs certain action. So it say it goes to the fire, and then it is the environment, fire is not good for it, so environment give the penalty in, that is basically reward, negative reward, -50. And -50 means this is bad, I'll not go to this side next time, or I'll try to avoid it. So this is how it learns. There is nothing like nobody is there to make it learn otherwise. It performs certain action and learn from it. So now you can understand the uh, on the right hand side, there is one agent, and agent takes certain action 80. That action goes to the environment, and then environment pass two things, reward and the observation. And then the agent take the reward and observation, it follows certain kind of policy and update its own learning. So that is exactly what happened. It performs certain action, go to the fire side, and then the reward is minus negative reward, and then it follow a policy and update its learning that okay, next time I'll try to avoid it. So this is how this works, and this one is reinforcement learning, nowadays very popular. Why the things are changing? The reason is simple. Uh, when I say label data, so label data are very costly. Reason being they are being labeled. So say if you want to, if you have, means like if you want to see the image of X-ray, it's very easy. Go and do the Google, you'll find some X-ray image there. Or you can go to the clinic and say just I need an X-ray. But if you want to get it analyzed and you want to take a help of a doctor, so additional cost comes into it. So the label data are very costly, uh, and there are various other issues also there. While there are other data which are, I mean, not labeled and which are mostly of them are freely available. So people think of some techniques. Okay, can we understand the things in that way? So that is one of the reason to shift from that uh, that type of learning. That means supervised to reinforcement kind of learning. Large scale of machines come into the picture because now we are full of data, a lot of data, and there is a lot of variation in the data. We have sparse data, we have continuous, discrete images, numbers, and then we need to handle it. We need to see the connections between them. Then yes, how to handle and all these things there. This is very popular nowadays, which is known as your deep learning. Maybe some of the speakers they have already explained to you. Uh, uh, let's understand in a simple way. What we do is normally neural network is uh, we give one input and then observe the output and then see whether that output is okay or not, and if it is different from the known output, so there is an error, and we try to minimize the error by changing the weights. Basically, weights are basically connection between the neurons. So what we do is we update our weights in such a way that we can exactly map input output patterns. So that is exactly what we do in neural networks. And what exactly is happening that if my images or if my data are simple one, so I need a very simple network which can do this purpose. But if my data are huge or they are complex enough, then we need a bit uh, bigger network. And as we keep on increasing the network, you'll find that then there are certain kind of other challenges come into the picture. Uh, Challenge of training the weights and all these things there. What is the process? So process always learning process is always in two form. One is training. So what we do in training, we take certain samples whose output are known to us. We just give the samples, check out the output, find out the error, modify the weights in such a way that the error is removed. And the second one is the testing, which is basically we know the output, but that is not being used while doing the training process. So we give the new input and check it out, check the output whether it's correctly done or not. This is normally the process. But again, a lot of other things are very important here, and the important part is like in your figure, I want to see whether this is a cat or dog. I need to give inputs in certain kind of features. Okay, let's see. I want to identify whether it's a cosine wave or it's a sine wave, or something else. Or it's a pure sinusoidal or not a pure sinusoidal. Let's take it that way. So then I have to give certain inputs in certain form. Say I'll go for peak. What is the peak value? What is RMS value? Or what is the frequency or something like that? Okay. So and then I give it to the neural network to identify whether it's a pure cosine sinusoidal waveform, or it's a mixture of certain other waveforms. So whatever these things like uh, inputs like giving the peak value or the frequency or RMS, these are known as features. So most of time, if I'm using a simple network, my accuracy of network and my identification accuracy, that depends upon how good are my features. And that is really a challenge basically, because okay, for few things, okay, you are good to find out the features, but in many of the cases which are new, it's difficult to get the appropriate features, and then how to do it. So people shift from conventional neural network to a deep neural network. In that, they say let the new network to find out the feature of its own, rather than we give the features. So we give the raw image as such and let the network to find out the features and then to identify. and that's why this one is, you can see, we earlier we use, when we are going for simple neural network, we use fatty network. Fatty means my hidden layer, there are lot of neurons in the hidden layer. But when I'm going looking for a deep neural network, I'll find I'm going to the depth. So it's not a fatty network, but it's a lengthy network. So you'll find more number of hidden layers, but the number of hidden neurons are less. And then people talk about other approaches like convolution methods and all this, so that they can make these algorithms, deep learning algorithms, as effective as possible. Yeah, this one is but obvious when we are saying that, okay, how to make my machine intelligent. So robotics, it's a perfect application domain for application of your AI, and it is very challenging in the sense, uh, there is a dynamics involved in it. There is a real system. There is a system which is keep on changing its coordinates, and at the same time it is getting a inputs through the sensors, and a lot of processing are occurring there. So this one is a really for engineers a really a challenging domain when you talk about yeah, robotics and combination of robotics with AI. Yeah, computer vision. Many of applications, I think, either you have seen it, or uh, you are using it. Right side, some of the applications of the computer vision. You can say visual navigation, when your bot is there and you put camera on the bot and it try to identify where is the obstacle and all that. Augmented reality is the, it's a very interesting domain where people have implemented to create the virtual things in front of you. Character recognition, okay, surveillance is the 3D object recognition. Games, it's a full of that. 3D reconstruction, segmentation, human computer interface, automation, and all this. There are a lot and lot of applications when we say that application of the computer vision. And on the left hand side, you can see here uh, videos frames are coming. We are using certain kind of detection algorithms, and then we merge them, and then we try to track the object, and then we do a lot and lot of things from there. Okay, many applications in a way. Yeah, you can find out, okay, what is the body temperature if your thermal cameras are there, and so you can the auto tagging of the temperatures. You can have tagging of the vehicles. You can have, if these videos are of a classroom, you can do a tagging of the students who are not interested in lectures. You can have a lot of applications. This one is just to give idea how it's happening there. There are enormous number of applications which are where we are using a computer as a system to analyze the images, computer vision, and obviously at the background we run our AI or machine learning algorithms to extract the required information out of it. NLP, right side, you see the applications. Now these applications we are already doing. We have unlabeled data also in various forms. I told you it's a cheap or low cost. We have labeled data which is costly. We pass this data to statistical machine learning approaches or simple machine learning approaches for many things, like document summarization. So you just send many things there and it will be summarized by your computing system in a very nice way. Uh, it can be a spam filter for your mails. So I filter it out automatically, that which what are the spam mails and non-spam mails. It can be used for machine translation, okay, converting one language to another, Korean to Hindi or to English to French or something like that. It can be information retrieval, that okay, you have information and then you want to see, okay, which where this is given and something like that. Sentiment analysis, you take few words, say tutor words or some other words, and then you can analyze from there whether the person is positive about that particular thing or he's thinking negative about that particular thing. And such type of applications are now very popular. Right now we everybody is talking about fake news, and very challenging. And yeah, it needs our we people, engineers and mathematicians to look at that how to identify the fake news and all these things. Automatic identification. Manually, yes, we can do, but it takes a lot of time, and it's not it's a difficult when we say that finding the fake news for yes, from so many news channels and all these things. These things can be done there, and the approach is there. On the left hand side we have either spoke words, we have some kind of a signals, and then we extract certain kind of information from there. We try to find out the similarities, and then we try to visualize the things, and finally end up that how the things are happening in actual way. This one is uh, uh, this area is speaking very fast. That is IoT. Reason is very simple. Now my sensors, my devices, they have a transmission and receiving facilities, so they can take the data and transmit the data in a very big way. And because of that, uh, we have a sharing of the data, and since they can communicate, they can develop a simple network of its own. And you can see the applications: IT networks, security, retail, transportation, industrial, healthcare, consumer, energy, and then you can see the subsections there. Lot of applications are being there. Like if I talk about transportation, then we can say transportation system, non vehicular vehicles, and then we talk about vehicles, lights, ships, planes, and lot those applications are there. So this thing is there, and at the same time, if we talk about electrical engineering, these things in some or another form we are using in electrical grid. Those are known as smart grid, and in future we'll say another thing, that is Internet of Energy things, because when we talk about electrical grids, we talk about electrical energy, and then we can say that okay, these are the energy grids. But the concept, the idea is the same. We are using a lot of sensors there. Those sensors give us the information. And yes, we know in electrical engineering, electrical your communication signals are much faster or speedy than your electrical signals, and you can have a certain kind of another kind of a vision over the things, that you can go for uh, better and smooth control of the things if you follow such type of scenarios there. So this one is another domain, because here we have data generated by the various sensors, but the difficult task is again how to analyze them and then how to connect them with each other. This one is just to give you one idea, which is the about the development in your uh, in your machine learning or AI, and the segment is basically where we are copying or mimicking our brain process. So you can see the right side slide there. It's somewhere beginning was in 1928. Then certain model on learning comes into the picture, and then breakthrough comes in 40, and the proposal which is finally accepted in a very big way, and that is basically HAPS learning model. So that comes there, and then some improvements in 1960 there, and it keep on changing. These are the learning models. So we have HAPS learning, and then some representation neurons, and then temporal coding, and then population representation. And from there you can see in between some different things come out there. Like if you talk about neuroscience and psychology, so that is data driven approaches. And then okay, uh, your in 1943 MCP, first neural network model, comes into the picture, and 1958 perception developed, perception picture, and then Hopefield, where the concept of basically memory comes start building up. That is comes in 1982, and again then we have branches, and then yes, Professor Hinton from Canada, he developed or he put the revolutionized the things by putting your deep learning to the picture there. We parallelly statistical machines keep on working. We have decision tree, we have a Bayesian network, we have support vector machine in 95, then random forest in 2001, and the another branch is there which is dynamic machine learning. So like reinforcement in 1961, then Markov models which comes into picture 89, and then dynamic Bayesian nets in 2002, and some hybridization and keep on upgradation on the things. Things keep on changing, and that is basically a pipeline. That is basically the development how it be evolved since 1928 when people thought of how to model learning, and now we are in a process not only learning but certain kind of graphs and networks and theories around that. They have implemented in various sections there. Okay, some successful stories is like testing the things to play the game, which is Go game, and mm, it's a very interesting in the sense that not only one step you need to think of. You need to think of, okay, if I move this, and then what are the possibles he can move, and then what I can do next, and going in that particular uh, particular states, and then you can think of, okay, what should be the most optimal strategy so that I can win certain. So this is one kind of like people have developed it and how they have done it. Another one, chess, which is again uh, uh, challenging uh, domain to check it whether how your computer and machine if they play with each other. So these are the various methods people have used uh, in your to develop some AI technique so that uh, computing system I can mm, beat humans or something like that. We are where they have gone for pattern recognition and min-max algorithm, alpha beta pruning, and iterative method, Monte Carlo tree search, and likewise. And these are the various developments they develop it so that they can beat the humans and something like that. I mean, these are some, why people are doing it. They are applying certain kind of techniques so that they put it practically to the people, practically to the humans, and they want to see whether the humans can beat machines or machine can beat humans, or what more can be added to enhance the uh, learning capabilities of few machines there. So again, coming to that part here, we have seen that there are enormous applications in various domains of your AI. So some of them, these are directly related to the particular sectors, and they are using it. So the governance, basically, and when I talk about the governance, these are the certain sectors like agriculture, security, healthcare, and social media. And, I mean, they are using it AI techniques to govern what. So the govern, they try to use find out the various patterns from the data which are captured from various domains for crime prevention, disaster response, traffic control, maintenance of public infrastructure. So when we are doing anything in anything on most of the time when you do anything on the network and internet and all these things, so we are pumping in our certain kind of inputs, and those inputs are certain kind of features which somehow reflect our thoughts, our beliefs, our what we want to convey, and then from there we can use these techniques to infer that what is running in the background of your mind, and from there they can have some kind of meaningful information. Some particular applications, uh, yeah, it is 3:30. So how much time we can I can take more, means like it's going to be 1 hour. How much more time is there for me?
So I think you can continue for 3:30, 3:45. So no issues because this is the last session we are having
Okay.
for today.
Okay. So I move a bit fast so that I can share some of the case studies. So
Yeah,
healthcare.
sure, sir. You can take
Okay.
your time, sir. You can take your time, actually.
Okay, fine. Thank you. So in healthcare, like we have automated disease detection, and I think many of you have experienced this thing. Most of time nowadays we have machines, MRI machines or PET scans or something. They already give certain kind of recommendations there. Later that is approved by a doctor. So that is basically one area where which is automated image detection, some kind of a diagnosis uh, workflow in the hospitals, because that is very challenging there. So rearrange the things, automatic arrangement of the things and all those things there. This is most important, and this is the costliest thing in the world in future, that is the basically data. So cyber security for data protection, lot of work. I think either you have observed it or you have seen it uh, from your experiences during last 2 years remote consultation. So doctors are somewhere else and then remotely they are assisting and all these things. Robotic assistive surgery nowadays it's a common in most of the good hospitals throughout the country in India as well. So the robot is an assistant to a doctor operating, and you can think of how what is the level of accuracy required, because say the robot is operating on the brain, doing brain surgery or something like that. So these are the areas where people have already successfully implemented AI techniques. This one is another one, like epidemiology. Basically, this one is this is nowadays since last 2 years. Okay, earlier it was also there, but since last 2 years, everybody is involved in it. That how this certain disease is spreading and how to control it. So it's a totally data-driven study, and then we take the data and then okay we analyze and find out certain recommendations based upon it. Everybody talking about the peak of the wave, coming of the third wave, end of the wave, and all these things there. So these are the certain snapshots taken from various websites, how it spread and how people have done it. So I'm just skipping it because everybody. Yes, the road traffic. Now there are few things which are very important when we talk about electric vehicles and this one traffic. One, prediction of the peak hours, very important. Right now, what we have most of the places. Now they are trying to do it, but they are doing it manually. And that our traffic lights are they are fixed in the sense like okay, say one minute is for red and 20 seconds for yellow and say uh, 40 seconds or something like for green, but it should not be like that, because people most of time it is observed that uh, during certain hours some lanes or some zone is highly packed, during off peak hour or some other hours some other zone is highly packed. So it's not good to have a constant or fixed kind of lighting system. So and many more things can be done. So we need to understand that what are the peak hours, and then we need to predict it, so that can we have a dynamic traffic and light control system or something like that. Another one is emergency services. Most of time, yeah, we have seen certain kind of some casualty happening because of non availability of the tracks to emergency services and all that. uh, Identification of the traffic violators, nowadays it is there, even in the morning 5 o'clock, and if you are moving, if you are in Jaipur and moving through a JLN road and nobody is there, but if you are exceeding the speed of 60 kilometer, you'll find after 10 minutes or something you'll find a ticket on your mobile that okay you have exceed the speed at that particular zone, pay 500 rupees or something like that. So that is automatically identification of the speed numbers and connecting to your account. Everything is automated, something like that. And the part is obviously vehicles, stolen vehicle recovery, criminal identification. So these are the few things which are directly connected to it. In future we will have more complex kind of things coming. So when we are thinking of like okay, we will get electric vehicles, pure electric vehicles on the road, and then we are thinking of autonomous vehicle on the roads and something like that. So the scenario will be quite complex, and then yes, we need a high precise machine learning algorithms to address those issues there. Smart grid, those who are from electrical. So majorly we are using in demand side management, and then on on uh, on customer side also, generation side, demand side, customer. We try to see the behavior of a person. We are now thinking of a smart homes where yes, the behavior of person is very important. So how to predict that one, and then based upon that, how we can control the whole power or light or environment in a house so that energy saving is maximized, something like that. So this one is another area where defense is again now people are they are using it like war platforms and virtual platforms even, and then target recognition, processing the images and all these things, threats monitoring, maybe some physical activities or maybe cyber activities, and then how to handle all these things there. Lot of application now. Agriculture is full of this nowadays. What we are doing, we are looking for species identification, greenhouse management, looking for crop disease detection, farm management, pesticide information, mappings of the mapping for to estimate the crops and yields and likewise. So these are the few down where people have already implemented all these things. Some work I would like to share in a quick go so that we can see. So this one is one work which we are still working and we started long back. This one is conceptual picture. So what is the idea here is basically that a person who is having his brain active but rest of the body may be suffering from paralysis or something like that, so that he can move from one place to another place. So you can see the sensors at cap and the sensors there. These sensors basically capture the signals and the signals are then analyzed, and from there try to find out what is the thought inside the a person is thinking, like whether, and based upon that some kind of a decision can be taken whether to move forward, left, right, which is done by this automated wheelchair which you can see on your screen. Some work like we have done with the hospitals also. So this we started long back, and you can see here 2006 this gap. uh, these are sensors which are not inserted in the brain. So these are the surface sensors which give us signals like this. And then we use these signals to identify. So we performed few studies. We developed certain kind of a questionnaire, and then we took the help of the doctors also. So what we did, we put this cap on the person, give a questionnaire, ask the person to fill the answers without speaking anything, and then we pass that answer sheet to the doctors to analyze it. At the same time, use these signals to analyze in mathematical form. AI machine learning can normally say mathematical form, and then we try to predict out the IQ level of a person. So not only IQ, rest of the things you can also do that. Yeah, this one is basically done by one of my student with collaboration with IIT Delhi and MIT. So this one is basically predicting of your seizure. You can see here various frequency bands, and at the right side you can see the signals which are coming. And from there we try to find out the various bands and try to find out that location from where that that particular pain starts building up or something, some what that where it is happening in the brain, so that doctors can easily identify the particular location and all those things there. This one is also another work. This one is a concept. This figure is when we developed a prototype. Basically, this one is to support your arm. So sometimes a person get injured uh, and the muscle activity is gone. So how to support that person, or if he's in rehabilitation, then how to do it. So you can see here sensors are placed on the hand. So from there, active nerves where it can detect the things and then detect the signals, and then there's a processing unit at the top which process it, which we can estimate that okay what action he want to do, and then You can see the mechanical support, their gear mechanism to support that particular person. This one is another work which is supported by the government of Department of Science and Technology, Government of India, that is to analyze the gait. And this one is very interesting in the sense gait means how we move, and that is unique basically. You cannot copy gait. There are enormous application of the gait. We developed a laboratory here at MNIT, and where we can analyze the person gait basically. So what we do it, this one is a screenshot of pictures of that particular how it is being done. We have 4 cameras, and then from the background how we are doing. This one is a pipeline. Person, what we do, we frame the video, capture the video. We ask a person to move 5-6 steps, and then from video we have image frames. We apply a pre-processing technique, which is normally we do when we talk about the image processing. So we crop the video, find out the area of interest, remove the noise, remove any kind of unwanted signal there, and finally get the things. And then we try to find out what are the signatures. So signatures are basically how when we move, uh, we move our hand, shoulder, knee, and all joints in a particular fashion, and that is basically a signature, and that is unique. It's not like you cannot. It's not like you can copy exactly everybody's signature. So we faced lot of challenges here. We started uh, with passive markers, and then we compare with the active markers, perform certain experiment in dedicated laboratories, and then we shift from that to markerless, so that we can have we just take a video image, and from there we can get the signatures. And these signatures have very interesting features out there. So if I think video is there, I can show you very fast. I can move it very fast so that we can. Yeah, the person is loading a video here. This is later, and then give me a second or so that you can see it. Yeah, so there is, you can see that no background is very now rough background. You can see doors are there, everything is there, and we ask a person to move here. So since there is no movement, any movement, so we can say that nothing. All you can see trunk angle, hip angle, knee angle. There nothing there, and then as soon as the person comes into the picture, you can see that signatures start building up. So the person is there, and you can see uh, uh, the various joints are being tracked, they are being monitored, and the signatures are in the process. And these signatures then later can be used for many purposes, like can be used for security purpose. These signatures can be, so these are the signatures of a person, then you can analyze anything from there. So these signatures can be later used for security, medical, healthcare. I found very interesting research that signature, even watching this, analyzing this signature carefully, you can predict whether the person is diabetic or not, and something like that. You need not to take the blood, but only just taking signatures, you can do many more things there. This one is right now one work currently going on, basically to analyze osteoarthritis without going for uh, your scans. Scans means I can say X-ray scans. So and then try to develop a equivalent 3D model so that doctor can analyze that. Okay, here is the problem. So normally this one is the uh, 3D model we have developed. Normally the pain occurs because of the friction between the bones and normal joints, and normally we have certain kind of another mass which is present there and which separates these two bones. So when there is an interaction between the bones, if pain is there, so how, what is the deformity and all these things, this work is going on. We try to do it from the signals rather than going for X-rays and all these things. So these are certain results from there. This one is I'm just skipping so that we can go for human modeling is not right now of interest. Yeah, this one is one which we have implemented, and this one is basically for electrical engineers. It is important in the sense that When we are talking about microgrids and all that, we put an inverter at the PCC. And normally what will happen is because of faults, uh, sometime it's your inverter do perform mal-operation, and it perform the islanding of the circuitry. And because of that, many times uh, many issues related to health as well as to power appears. So here in this case, we proposed a solution that uh, we just monitor the uh, uh, current and voltage waveform, which is not very difficult, and we try to predict in advance that okay, something is going to happen, so that inverter can change its mode of operation. So that is one another thing. This is another work which where we are working. Just imagine that okay, someday your refrigerator tell you or show the things on your mobile that okay, I am now no more 5-star rated because you purchased me 5-10 years back and you overloaded me. So now my rating is, instead of 5-star, it is 3-star. I am consuming more power. And if you want to understand it in terms of money, so this much more losses in terms of monetary you are getting it. So better, my idea is to you replace me. So that is something like what we are expecting in the smart lobes. So what it is doing, it is capturing the signals every time and then try to predict it that okay, uh, estimated okay how long is the life of a particular electrical appliance is there. This one is another work which is we are expecting in homes, so smart homes. It's in connection with the smart homes. Again, I'm just skipping it. This one is another area where one student just completed his part of it. That is greenhouse, and why it is challenging. We need to create exactly a perfect atmosphere inside a greenhouse. Okay, and here many things are there. We need to maintain the humidity of the soil. We need to maintain the temperature. We need to maintain the airflow, whereas the outside temperature and everything is totally different, but inside we need to maintain exactly the perfect or most optimal, so that we can have we can maximize our production. And that is really very challenging because the things are quite complex and dynamic in nature. So this one is another area. This one is one example of reinforcement learning. I told you. So you can see here this video to understand the reinforcement learning. We developed it. Let me show you. You can see that the boat is moving here and it is avoiding this obstacle. Continue. And then moving towards its goal. Goal is to reach to the red one. Now the question is very simple, or anybody can ask, okay, what is big in it? Just you put a IR sensor, and when it move forward, and put a threshold that okay, from IR sensor it can easily detect it. And it will take either left turn or right turn. Well, it will perform. It will perform because you'll find such type of tools or toy cars in the market, $200. But here we try to develop something much complex. You can see there are two cameras which are being used to develop exactly like a human eye. So so that why two cameras? One camera is there, but you can use what is you can see what is there, but you cannot find the depth, how far it is. So we need depth when we are moving. So we use two cameras and to develop exactly like a human eye. And here we are not training it. We let it go. First time it move and hit the object, we put a penalty. Next time it may and put some policy in it. Next time it move and then try to avoid that one by taking certain angle. Again it hit, again certain kind of penalty. So we run it, we move this board set around 10,000 times, and then finally it come up with certain kind of a learning that okay, I have to avoid this obstacle. And then we perform it and in various we perform various case studies, like your obstacles are fixed, board is moving, and then uh, next case is your boat is moving, your obstacles are also moving, and then the next case is your boat is moving. Not only obstacles are moving, the number of obstacles are also changing randomly, so that we can get the realization of a kind of Google car or autonomous like vehicle can be there. This one is again, I'm skipping this one. This one is again an example, totally developed in the Raman lab, which is my lab at MNIT. Anybody who is interested can come and see. So this one is totally developed here, and the challenge is you can see degree of freedom. It has the highest degree of freedom, and to maintain the balancing of this one, because when we have more degree and the balancing is a very complex structure. But you can see the, you can just check the movement of the legs and the toes. It is trying to mimic exactly the like a human behavior, so that it can be used for further purpose. Oh, okay, this one we are short of time. This one is exactly like like a Sophia, if you heard about. It's totally exactly like that, even much before we have done it. Beta, it's a beta version. It recognizes you, it will talk to you, it give you the expressions, and then it try to solve your queries. Okay, you can ask. Okay, you can ask anything to this one. Also, next time, first time you have to introduce, next time when you come, then it will give you all kind of welcome note and all those things there, which is there already. This one is the swarm drone, which is still going on. That multi drones, how they are connected and they work with each other. We design the drones and we develop our own drones rather than getting it from here. We have a very small drone we developed, and yeah, I think the video you can see here. This one is in the internal auditorium, and it is a very stabilized drone, which is the demo is here only for the uh, with the manually operated. But what we are looking here is how to uh, make them autonomous, basically. And the another part is we have done a lot of a lot of work in this particular domain, just to put it there. Robotics, I'm just keeping note. Just these few 2 3 slides, and then we can conclude. In a mobility, electrical transport, when you talk about EV, we have various issues with EV, and one of the biggest issue is basically your charging station. How you will charge your EV? Do you want to charge it at your home, or you are looking for some charging stations? And then, if you're looking for the charging stations, where it should be, and then not only where it should be, but what should be the size of it. Okay, you have free area, free space, but is that particular is that location is good enough to support your electrical requirements? It may be possible that that particular node is overloaded, and then how the consumers are behaving. Okay, in petrol one, it's not a big thing. Like, okay, if the line is big, you can drop it and you can come or something. But in electric vehicles, uh, we have other issues are also there, because it's not like you are storing it somewhere. If you are storing, then it's a different story. But say if I am not storing it, then I have to tell how much is my load, and then accordingly I have to pay the things, and a lot of complexities are there. So this one is one of the area which is very important and very suitable for the application of AI techniques. This I already discussed with you. Detecting the traffic, looking for all possible solution to remove the congestion on the roads, predicting the peaks of the traffic, and then these vehicles will be having a lot of data, and then how we can use those data uh, for enhancing the quality of the traffic on the roads there. We perform certain kind of analysis, not and using Google APIs and all that, and then using some ML technique, and that is basically a motion planning. So sometimes, okay, we are looking for point A to B. You will find that it's good for Jaipur, because this we did because Jaipur is a funded to be a smart city. So we have parallel movements, and sometimes you find that, okay, path A to B is short path, but during evening it is highly congested, where path B is a bit longer. But when you finally come into the compare the fuel consumption, you'll find that though the path B is a longer path, but if you follow that one, then you can save more fuel. So those things are very important when we go for motion planning and all these things, and that will help not only saving the fuel, but also providing an alter solution so that the congestion on the roads can be eliminated like this. There are many things, many other things which we are doing there. So sorry, it is already being late. I'm just uh, um, putting it. I'm towards the end, and this is the last slide. I can say thank you slide. If you have queries, let me know if you have queries, so that I'll try to answer your queries.
Okay, thank you so much, Rajesh sir. So I'll give the attendees, the participants, probably and the opportunity to ask the question.
You can enable their comment
Yes.
box so that if they write their queries, and I'll try to answer their queries.
Right, and I have also enabled their mic as well. Okay, so
Okay,
anybody having
okay, fine,
question,
fine. That will be good
they can.
because I cannot see the chat enabled yet.
Okay. Yes. So anyone having any question? Participants, Dr. Rajesh is here with us to answer all your queries regarding the session.
Yeah, not only for this one, but if you have another idea, you want to use AI or you want to develop something, and if you want to have my inputs for that, yeah, please put your question.
Sir, as you have mentioned that you have a, mentor in Raman Lab, so right now we are in the Madhya Pradesh region, so virtually we can access some IoT kits, or we can simulate the code on IoT kits somehow.
Yeah, those facilities. See, there are things. Two important part are there. See, if you want to do it virtually, then yeah, I need to take a permission from the institute, and then yeah, through the institute cloud you can do. So that is one thing, and the second part is if you yeah, working on certain thing, if you stuck up somewhere, you just mail us. We will support you either in terms of some kind of document or in terms of some kind of inputs that okay, try to do it like this, not like that. That support is directly we can answer to your questions.
Yes, yes. So, sir, kindly paste your mail ID on the chat box so that we can comment it.
My chat is not enabled. I'm just waiting it to be enabled.
Okay.
Sir, can you just mention your email ID, or we will share from our side if it's okay for you. There may be some problem with the chat section. Uh, so, so if you allow, then from our organizer side, we will share your.
Okay, I'll give you the simplest way. Those who are listening, just search Google search Rajesh Kumar MNIT. I think you'll get my website, and on it you will find a lot of presentations. Some codes are also there. A lot of research problems are also there. My mail ID and other details are also there.
Okay, sir.
Either you search Rajesh Kumar MNIT or you can search Raman Lab MNIT. Both are they are interconnected, so you can get it.
Thank you, sir.
Yeah. Any question? So if no more questions, then we can close them.
Sir, we will have some group photo, sir.
Okay. So you want me to turn on my?
Yeah, you.
Video.
Yeah, and the participants also to turn on their camera so that we can have a group photo for the session.
Is it okay?
Yes, sir. Thank you. Thank you, sir.
Yeah, thank you everyone. Yeah. Thank you. Thanks a lot.
Thank you, sir.
It was a nice meet you all. Thank you very much.
Thank you, sir. It was a nice session. Okay, so I think now we can end the sessions for today. Okay, and please fill up the feedback and the attendance forms. I'll share the links are already shared in the chat in the group. I'll just share it in the chat as well.
Chat box is not available to us, sir. That is the problem.
Actually, the only thing is you need to log in. You need to make sure that you need to log in through the registered or the provided email ID.
Same,
Because
I'm doing the same, sir. I'm doing the same. I don't know what exactly the problem is. It's not enabling. I had given them my mail ID as well. Both IDs I had given. I don't know what is the problem.
Okay, so
Send in the WhatsApp group only, sir, if possible.
it has been sent in the WhatsApp group. It is
Then
already
no
shared.
problem. Then no problem. Then no
It
problem.
has already been shared in the WhatsApp group.
Not yet shared, sir. It's shared? I don't think so.
I'll just check. Okay, I'll share it.
Session 3 is not yet shared, sir. Thank you.
Okay, share the feedback link, attendance link, and I'll also share the feedback link as well. Okay, so both the links are now available in the WhatsApp group as well.
Sir. Thank you. Thank you, sir. Available now.
Okay. Okay, so thank you everyone for attending the sessions. We will meet again tomorrow in our next session. And if you have any problem, any queries regarding any session, you can put up in our WhatsApp group. Thank you everyone. Thank you.
Thank you, sir. Thank you, sir.